Okay, so in this video, we're going to talk about different types of functions. We're going to start with the linear function, the most common functions of them all, linear function. And on the Cartesian plane, the linear function is sort of this straight line function. So you have our x's, and a linear function is sort of just a straight line, with this being x and this is y. So this is a linear function, just basically a straight function, and this is a relationship between y and x, and the equation for a linear function is y, we can say f of x. Let's rather use f of x, because remember, y is a function of x. The value of y depends on x. So writing this as y, sorry about that, writing this as y is equals to x is the same as y, is same as f of x is equals to x. So with this being said, then y is actually equal to f of x. So with this in mind, I can actually write this equation as f of x is equals to, so this has to be in brackets because x is the input, right? X is the input for f, so we have to put that in bracket to show that this is a relationship. It's equals to mx plus c. This is the equation for this function here, right? The equation for a straight line function is y is equals to mx plus c. Now this is a linear function. Now the next type of function that we're going to talk about, a quadratic function. So we're going to talk about a quadratic function. So the reason why I chose a quadratic next is because this is x to the power of 1, and a quadratic function is basically x to the power of 2. So the general equation for this is f of x is equals to ax2 plus bx1 plus c being a constant. So a is a coefficient of x squared, b is a coefficient of x, and then we have c is a constant. And on the Cartesian plane for this has a sort of a, okay, let me draw it like in the middle, and then and our graph has the shape of a parabola like this. So this is a sort of a shape of a quadratic function like this, or whichever one. It's sort of a u-shaped function. So this is a quadratic function, and this is the general equation for this quadratic function. And now the other type of function that I want to talk about is a hyperbola. And we can call it, this is a hyperbolic function, but it's called a hyperbola. And the shape of a hyperbola looks like this. And then it comes from this side and it goes down. So this is the shape of a hyperbola. Let me turn this off. And the equation for that is f of x for this is f of x is equals to 1 over x. You know, usually it's the actual equation is 1 over a x plus a. It's 1 over x minus p plus q. So this is the equation of a hyperbola, right? So yes. So now we're also going to talk about the exponential function. And the shape of an exponential function is and the function is f of x is equals to, so let me do this in white. Let's say f of x is equals to x in some variable n. Now these are the equations that I'm writing like this. This is a translated form, but the general form for this, it's just, you know, y is equals to, for this is the hyperbola, this is 1 over x over x. This is the untranslated form of this particular graph, and for this is just f of x is equals to x squared. So this is raised to the power of 2, and for this one here, it's y is equals to x. And all of these graphs that I'm drawing, they're not translated, except for this one here that's supposed to be sitting on the x's, but we can fix that. We can just draw the x's right there where they are actually supposed to be. It's supposed to be in red. So basically what I'm trying to point out is that this is the untranslated form of the graph of the y of this particular graph This is when it's not translated, and we're going to talk about translation soon in another video, but here I'm just introducing the graph. So this is the exponential function, and the other type of a function that we're going to talk about is a polynomial function. Now, these type of functions here that I was drawing, these are sort of the entry level functions, right? Now, when it comes to other types of a function like a polynomial function is basically a function that is, so let me write here, function, and this is a type of a function where f of x is equals to some a n x to the power of n plus a n minus 1 x to the power of n minus 1. But in general, what this is alluding to is we have some sort of a function f of x, or let me say, I'm giving an example here. We have some sort of a function f of x is equals to, let's say for example, 2x to the power of 6 and then minus x to the power of 5 plus x, or you can even say 5x to the power of 3, and as it goes with some constant at the end, right? So this here is we're gonna get to some constant at the end. We're gonna say plus some constant a with an n. So this is some terrible writing here. Let me just fix that. So if I zoom in here, so that I'm just creating space. So we're saying that we're going to get to some a, because we keep on subtracting the value here. A is going to get to 0. And also n minus 1 is also going to get to 0. But remember, when x of n minus 1, if I can just point to this real quick. When we have x minus 1 and then it gets to 0. Let's say it gets to a point where it's 0. Remember, anything to the power of 0 is 1. So when we're talking about this ax to the power of 0, it's actually still x to the power of 0. But because this is just going to evaluate to 1, we just end up just looking at a to the power of 0, and this ends up being a constant. So basically we can say every single constant when we're dealing with algebra can actually be multiplied by this. So this is the polynomial function. And this one here can also have some constant c, and we can say plus 7. Now to draw this graph now on the axis, we can draw this graph. In fact, let me actually pull out my graphing calculator here so that we can draw it and see exactly what it looks like. Okay, so here's a graph, but this particular graph that I drew, this is just f of x is equals to x to the power of 6, right? So this is f of x is equals to x to the power of 6, and I just drew it here by the side so that you guys can see the type of function that is a polynomial function. So I won't be able to write this. Let me change the color because it's white and I'm writing with a white pen. So this, you can say that this is just f of x is equals to x to the power of 6, right? But I'm not going to be, okay, I think I'm going to keep on drawing the types of functions that I'm going to have. I'm going to keep on giving examples, except for this other one called the piecewise function. I'm going to draw it by pen, right? So let's talk about other types of functions. So this is a polynomial function because it has some degrees and it has all of these constants that are coming after it. But in actuality, this is also under a family of functions called power functions. So let's talk about those. Power functions. Sorry, I don't know if you can hear the noise in the background. I'm sorry about that. But power functions is just some function that is f of x, right? And it's equals to x to the power of n. So x to some exponent n. So this could be anything like x to the 5 or x to the 6 or x to the 7. This is called a power function. But a polynomial, what differentiates a power function and a polynomial is that this is a power function. A polynomial, however, has these multiple terms, right? It is a polynomial number. It is a lot of terms. Poly means many. So it is a lot of terms, and that's what separates this from a power function. And we already have an example for this. I mean, I could just paste the same thing there on the power functions to say that it's some x raised to some integer n, and we can just say this is x to the n, because I mean, you don't really know what x this is, but obviously, I mean, by looking at it you can tell that it's an even function, but that's also a topic for another day. Let's talk about these things called rational functions. That's another thing we're talking about. Now, from now on, I'm just going to be writing the equations, because some of these functions, they really need an example to draw. And right now, I just want to introduce the functions, and then we'll go into more detail about each one of them in another video. So right now, let's talk about a rational function. And so this is an equation where f of x is equals to some function. It's actually two functions on top of each other. So we have some sort of p of x here on top over q of x. And the way, if I were to draw a rational function, I could say here e.g. Okay, without drawing, if I could write an equation of a rational function, this would be e.g. So we can say f of x is equals to 2x to the power of 4 minus x squared plus 1. All this is over x squared minus 4. Now you can see that the function on top is a function on its own, and here what's here at the bottom is also a function on its own. This is here x to the power of 4. This is a polynomial. You can see this is a quadratic equation, x to the power of 2, and those are two different functions on their own. Now let me give an example of what this is going to look like in an actual graphing calculator. Okay, so this is it right here. This is this exact function. The equation for that is this, for this exact function here. Now this is just an example. I'm not saying all polynomial functions will look like this, because polynomial functions can get pretty crazy, and we don't want to talk about, this is an introductory video, so we don't want to talk about anything that is deep, right? So the other type of function that I want to talk about is this thing's called an algebraic function, right? So this is an algebraic function. And now the general equation for this is, it's pretty tricky. There is no general equation for this, but however, I can give you an idea of what an algebraic function looks like, because basically an algebraic function is a function that is put together. Let me write a short description here to say that this is a function that is constructed, a function constructed using algebraic operations. Yeah, might have to zoom in again here. Okay, operations such as addition, subtraction, addition, multiplication, and division, and taking roots. Now when I say this is the definition of an algebraic function, but now the equation for this, right? Let me give you an example of an equation that is an algebraic function. So f of x is equals to x to the power of 4 minus 16x squared. All this is over x plus the root of x, and all of this is plus x minus 2. So about that, x minus 2 to the power of this is not a power, this is x minus 2 is being multiplied by x plus 1. So this is an example of an algebraic function. It's just mixed up together. You can see here there's a root, here there's a root. I'm multiplying this with the roots, and obviously there's a way to plot this graph, but I mean, you know, you can try this out. Actually, you can try it out in your own graphing calculator. The one that I use is Desmos. I'm sure you saw me when I clicked on it. This is Desmos, you see, Desmos. But yeah, that's the one that I use. It's a pretty cool calculator. The other types of functions that I want to talk about is the trig functions. So we have a family of functions called trig functions. And okay, sorry, trig actually stands for trigonometric. I don't know why I decided. Let me just put it here to say trigonometric. Trigonometric functions. So trig stands for trigonometric functions, and we have a couple examples. We have the sine, and then we have the cos. We have the sine function. So this is sine of x, and the way this looks is and the shape is sort of starting from 0, go down, go up, right, and it goes from 0. So this is going from 0, this is at pi over 2 to 2 pi, and it goes up to 1, and it goes down to what, to -1. So this point here happens to be -1. So this is a trig function. This is a simple representation of a trig function, and this is the shape. So it actually is a continuous function, so it can actually keep going and going and going up till forever, but I just wanted one that is bound. So let me say this is when f of x is equals to that, and we can say that this is bound from 0 all the way to 2 pi, right? Now this is a trig function. This is a sine function. Starting from 0, it goes up to 1, goes down to 1, and then goes here. Then other type of function that we're going to talk about is a cos function. Actually, this is just an example of a trig function. We're not talking about trig function. Excuse me. This is an example of a trig function. And then now the next one that I want to talk about is so we talked about this type of an exponential function. Where is it? We talked about this type of an exponential function. There is another, however, type of an exponential function where f of x, or let me say g instead. Let me say g of x is some number e to the x. E to the x is a type of an exponential function. Now those are the other type of functions that I wanted to talk about, but because I've already mentioned it here, I don't see the point, right? We can go into detail more in a dedicated video, but for now, the last type of functions that I want to talk about is I want to talk about logarithmic functions. Those are the only type of functions that are left. So logarithmic functions, right? Why is this thing refusing to give me an arrow? It's fine. Anyways, lastly, we're going to talk about logarithmic functions. And basically, a logarithmic function is a function that has a log in it. So I mean, it's literally as simple as that. It's f of x is equals to some log, sorry about that, it's equal to some log to the log with base a with some x. So this is the general equation for that, and the shape of a logarithmic function. Oh, actually, I should have done this like this. Let me select this, and then we're just gonna move it up here, because the logarithmic function actually goes like this. Okay, so that's it for this video. We talked about different types of functions. If you want those notes, there's notes, because this is a PDF that I'm using here. If you want those notes, you just comment down below and then I can send it to you. You can comment down below that you want the notes or whatever, how I can have the notes. You know, just be kind. Don't say, hey, yo, give me the notes. But yeah, you're allowed to say that, hey, yo, give me that. I don't feel like that's not kind. But if you want those notes, I can send them to you. But yeah, that's it for this video. Thanks for watching.